Hello and welcome to this video, and in this video we are going to start magnetic fields. So magnetic fields is going to be slightly different from the gravitational fields and the electric fields that we've looked at, just because we're going to look less at the ideas of potentials and field strengths and stuff like that and investigate how they behave in a magnetic field. We're going to look a lot more strongly on the applications of magnetic fields. Since magnetic fields tend to be very useful things, we literally use them every day. You're using magnetic fields, or you've used magnetic fields to get this video to play on your screen, because you need that electricity from a magnetic field. And so it's very important that we look at these magnetic fields. We look at how do we actually use magnetic fields in everyday life, and how would we use them from a scientific perspective. So we're first going to introduce a similar way that we introduced gravitational fields and electric fields. We're going to look at the field lines. Okay, so field lines for a magnetic field is going to be different depending on what we're looking at. The difference between having an electric field or a gravitational field to a magnetic field is that you can have just one source with a gravitational field or an electric field, but in magnetic fields we have to have a north and a south pole. So we must have both north and south poles. There are currently no existing monopoles that we know of. It's kind of a whole thing in physics right now. Everyone's trying to create a monopole, but it's very difficult to actually even conceive the idea of a monopole. But we have to have both north and south poles. Examples of things that have north and south poles, probably the biggest one that you know is the Earth, right? We have a north pole, we have a south pole, and that's not just there to point to north and point to south. This is actually the magnetic field of the Earth. So if I were to look at the equivalent of a radial field, although it's not necessarily radial anymore, so I'm going to put this in speech marks, is I could have the Earth, where I have a north pole here and a south pole here. So this is north, this is south, and the field lines always from north to south. Okay, we always start at north, we end up at south. We need a direction because that's the direction that charges will flow in. And so the Earth's field lines look something like this, and they will go gradually out and so on. Okay, and again they have to travel from north to south. Now we're neglecting here the field lines inside the Earth because we're not too sure of what actually happens there. We could also look at a bar magnet, and a bar magnet, so something that you might put on a fridge, will be split, so it has a north pole on this side and a south pole on this side, and the field lines are going to travel in a very similar fashion from north to south. Okay, and they're going from north to south, so they're all traveling in this direction. Now this is what the field lines look like, and this isn't going to be that useful for the most part. We are going to look mostly at the field lines when we're looking at forces and electromagnetic induction. Those are the two big parts that we need field lines for. But we can also, in the case of magnetic fields, since they're similar to electric fields, because it's the electromagnetic force, they both act on charges, we can also get a uniform field. Now a uniform field is going to, in the similar way that the uniform field in electric fields was just a plate that was positive and a plate that was negative, we can just connect two bar magnets. So I have the north side here, I'm obviously going to have the south side over here, and then I have the south side here and the north side here, and in between here I will get a uniform field, because as I move these closer they will end up producing this uniform field. And similar to the plates, there will end up being some curvature at the ends. But for the most part, we can assume that that's negligible, so we just focus on the bits in the middle. So now we have basically our introduction. Our introduction is just to imagine what the field lines look like. We're then going to go into forces. We're going to look at forces on a current carrying wire. Then we're going to look at forces on a free moving electron or free moving proton, just anything that's charged. And then we're going to start to look more in the applications of the magnetic fields and how to generate electricity. From this video, the important things you need to know is that we can have both radial and uniform fields, and they both, all magnets have to have a north and south, and the field lines will always travel from north to south. Thank you for watching.